Hello everyone, Assalamu alaikum. Before I begin, let me introduce myself briefly. I'm Tamanna Kaonain. I'm a Master's by Research student in Malaysia Japan International Institute of Technology, University Technology Malaysia, Kuala Lumpur. And I'm under supervision of Dr. Azizi. My co-supervisor is Dr. Hatta. Today, I'm going to be talking about collaborative robot safety for human-robot interaction in domestic simulated environments. I will begin by outlining my presentation, its introduction, literature review, methodology, results, conclusions, and references. Firstly, I would like to talk about the idea behind this research study. There are different types of human-robot interaction or HRI, such as cooperation and collaboration. There are few examples of HRI here. At the top, both pictures are examples of human-robot collaboration, sharing same workspace. At the bottom left, the image is a simulated HRI, and the last examples of an animated movie's picture on human-robot collaboration. The risk of injury to humans is the most important challenge during HRI. In industrial robotic systems, robots are mostly cased in a safety guard atmosphere and isolated from humans. Mechanical design on its own is not adequate for unstructured environments such as domestic area to ensure secure and human-friendly interaction. So, safety measures using control and planning of the system are required. In order to ensure safe interaction, the robot must be able to assess and reduce the degree of risk in its current environment. So, to update everybody about the latest in this field, that human cobot collaboration is safe. Why is it safe? Why cobot is used? Cobots are lightweight and convenient. It accepts less programming skills to set up these robots. It needs less time to develop this kind of robot. It is possible to share same workspace without safety fence in human cobot collaboration. It is possible to secure and human-friendly interaction between cobot and human. It can be used safely in the home environment. This is the main focus of this research study. Let's show you the findings from the literature review. I would like to briefly talk about this. Berg et al. In 2017 research on cooperation between human and robot, where the robot is isolated from human in a safety guard environment. In 2018, Yu et al.'s research was on collaboration of human and robot, which is not adequate to ensure safe and human-friendly interaction. In 2019, the research on interaction between human and robot in indoor environment was done by Demir et al. The environment is not a proper domestic area. This is the methodology will be applied in this research study. This is the research outline. In the starting from the literature review, a HRI model will be designed in the Gazebo simulator. Then that model will be investigated in the simulation. After investigation, the safety property will be evaluated in the HRI. If it is not safe, then the investigation will be repeated. But if it is safe, then the model will be validated with a recent benchmark problem. After validation, a report will be made and a paper will be published. And then the research will be completed. Now I'm going to describe the proposed model. Firstly, the cobot will locate the safest configuration. Then it will make sure that is there any obstacle or not. If not, then it will move to forward path. If yes, then it will identify what obstacle is this. If it's not human, then it will go to backward path. But if it is fine, it's human, then it will reduce its speed. After that, it will check the risks. If there is no risk, then it will move to forward, then it will search its final destination. But if there is risk, then it will minimize the level of danger. Next, it will check the interaction is safe or not. If not, then it will reduce its speed or stop there. If it finds the interaction is safe, then it will move to forward path. Finally, it will search for its goal. If it finds its goal, then the task will be completed and the error will be returned if it finds from its entire journey. This slide shows interaction system overview. At the top right, this block diagram is the Markov decision process with the agent to environment interaction. The process is implemented to simulated arm robot in the domestic area. And the bottom right, the picture is that simulated arm robot. From the figure, it can be described depending upon the environment and the state. The agent performs action and receives reward, which are briefly discussed here. Here are the some works which are already done, and the findings are domestic environment. Domestic environment is created in the Gazebo in order to navigate the robot. Gazebo simulation development. Controlling the action taken by the arm robot in the interaction with the human in the Gazebo simulation world. In this slide, a simulated domestic environment is shown here, which is designed in the Gazebo simulator. Here, a robot, an arm robot, and interaction between human and robot is shown. This research study's expected findings are here. The safety of human-robot interactions can be simulated. If a robot detects a human, then the robot reduces its speed and checks the risk factor of their interaction. If there is no risk, then it can move forward. But if any risk is still there, it tries to minimize the danger or stop there. The motion speed can be reduced. Using the Gazebo environment variable, the motion speed of an arm robot can be increased or decreased in real time by using ROS control and a Gazebo, basic Gazebo plugin adapter. The number of collisions does not exceed 2 times out of every trials. Each robot assumes some responsibility for each pair conflict, with the resulting constraints providing a range of variation on speeds from which to choose using linear programming. After all the work and research done so far, here is a summary. In order to achieve the objective of this research study, a systematic process will be developed for ensuring safety during human-robot interaction in a domestic environment, based on an explicit quantification of the level of danger in the interaction using ROS-based Gazebo simulator. A method for assessing the level of risks at both the planning and control stages will be developed. To accomplish the desired task of moving to the goal with the probability of collision with a human, evaluation trajectory fitness will be applied. The method will be investigated into physical system components that have been integrated and validated on a robot platform during real-time human-robot interaction and tested. These are the references. I hope you like this presentation and I hope you would like to have a robot as your personal assistant. That's what I dream. Thank you very much.